A lot of times it's very easy for us to say things like, inside of the cell, this molecule goes over and it interacts with this thing. But the question really becomes, is inside of a cell, how are things getting from one place to another? And how do they really know that that's where they're supposed to go? Well, inside of the cell, there are microtubules that help make up components of the cytoskeleton, but they are heavily involved in intracellular trafficking. They serve as the roadways for the cells, right? And a microtubule is made up of something known as tubulin. And tubulin is a dimer-based molecule. So it has an alpha and a beta subunit to it. So two subunits, right? It has an alpha subunit and it has a beta subunit. Okay? And the alpha subunit tends to have a negative charge, whereas the beta subunit has a positive charge. Okay? Now, these dimers sort of come together so that they make up something known as a protofilament. So what happens is you get a stack of them, something like this. And you can sort of see the point, right? And this is known as your protofilament. So this is a protofilament. Okay? And those tubulin dimers then sort of interact so that they make this like sheet of dimers. It's a sheet of protofilaments. So we do something like this, and then these dimers sort of make this sheet. And one could see that this sheet would then sort of spin or roll up on itself, and you would have sort of a rod-like structure. And when that happens, that rod-like structure then becomes your microtubule. Okay? So I'm just going to put sort of an arrow like that to show that this is going to spin and roll up on itself. And that's going to create your microtubule. Okay? And what you can see then is that the microtubule is going to have a negative end, and it's going to have a positive end. And that's going to become important here in just a second. Now, if we have a cell, draw sort of a big cell, what we have is that there is a portion of the cell which is known as the microtubule organization center, what's called the MTOC, and microtubules sort of like radiate out from that microtubule organization center, right? And this provides the highways or the roadways that this cargo or this stuff is going to sort of move on. So if we look and we just say, let's say we have our microtubule and we have our dimers, and I'm just going to draw two here, but imagine this is the rod shape we talked about. And we're going to speed up the process a little bit here. Like so. Here's our microtubule. Now, there are carrier molecules that walk along this microtubule. So they have like little feet, and they have the carrier molecule associated with it. Okay? So what happens is you have sort of like a foot with a leg, and then a foot with a leg, and then that's carrying something. We'll call that something X. And what happens is that foot will then swing over this way. So then you've got the foot here now, right? And then this foot will then go this way, right? And so this carrier molecule will sort of walk along that microtubule. And there are two main carrier molecules that we talk about. There is one known as dynein, and there is one known as kinesin. Okay. And these differ in the direction that they walk. So dynein is going to move towards the negative charge. Okay, so remember that microtubule has a positive end. Let's go back up here, right? It has a positive end and it has a negative end, right? So our dynein is going to move in that direction, right? So it's going to move, dynein will move in that direction, okay? So kinesin moves in the opposite direction. So kinesin moves towards the positive charge. So it moves towards the positive end, right? So it is going to move in this direction here, right? So we have dynein and kinesin, which are going to sort of carry things through the cell in different direction, and that helps get molecules and stuff to where they need to go.